Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistants. And today we are discussing oxidation and reduction reactions. So we are given the task of assigning oxidation states, or otherwise called oxidation numbers, to each element in the following compound. There are several rules for assigning oxidation states to various elements, but there are a few that show up regularly throughout your course. One of them is identifying that group 1 elements will be having an oxidation state of +1, and group 2 elements will have an oxidation state of +2. Hydrogen will have a +1 charge when it is attached to a non-metal, and it will have a -1 charge when attached to a metal. And then oxygen is usually our telltale whenever we're trying to assign oxidation states. It normally has a -2 as its oxidation state. There are two exceptions. If it is in a peroxide ion, then it'll have a -1 oxidation state. And if it is a superoxide as part of an ion, then it'll have a -1/2 oxidation state. But those two do not show up very regularly. So let's begin. We're going to start by rewriting our compound, Na2O. And above each element, we're going to put the oxidation states, recognizing that because there is no charge on this compound, that must mean that the oxidation states have to equal 0 when summed. So let's look at how we're going to assign this. Well, oxygen has a -2 whenever it's not a peroxide or superoxide. So we can make the equation down beneath that whatever this ends up being has to equal 0, and we have a -2 as our oxygen. Therefore, the total of sodium must be +2, because only 2 minus 2 equals 0. That's the only way to solve this particular equation in a reasonable fashion. But because there are 2 sodiums, we have to take this 2 and divide it by 2 to get the actual oxidation for sodium. So the oxidation state of sodium is +1, because we can then rewrite this if we need to as 1 sodium plus 1 sodium, because there are 2 sodiums, -2 for the oxygen, and that equals 0. So those are our oxidation states for that compound. Let's look at the next one. When we rewrite this and assign the oxidation states, again, our key indicator is going to be oxygen. So HClO3. Oxygen has a -2. And hydrogen is also a key indicator, because hydrogen is attached to a non-metal. So whenever hydrogen is attached to a non-metal, it has a +1 oxidation state. And we know that the total has to equal 0. So we have 1 plus some number, let's call it x, minus, or 2 times 3, because there are 3 oxygens. So that's the same as saying 1 plus x minus 6 is equal to 0. Well, if you isolate x, you'll find that x is equal to 5, because you would add 6 to both sides and then subtract 1 from both sides, or you can combine like terms and make it so that it's x minus 5 is equal to 0, and then add 5 to both sides to get x by itself, so x equals 5. So our determination is that chlorine has a +5 oxidation state. That's the odd man out. That's the one that is going to be a little trickier to find out because chlorine can have several different oxidation states. Let's look at this one more example. HPO4 2-. Let's rewrite this and we'll assign the oxidation states for it. So HPO4 2-. So we know that oxygen, again, is going to be a -2, and we know that hydrogen is going to be a +1. That's relatively simple. Now we need to find what phosphorus is. But because the charge on this particular ion, this particular compound, is a -2, it's 2-, we're going to say that our oxidation states have to equal -2 instead of 0. So we have 1 for the hydrogen plus some unknown value, let's call it x, plus 4 times -2, because there are 4 oxygens, so plus -8. You have 4 oxygens here. Each one has a -2 oxidation state. 4 times -2 is -8. If you combine like terms, you end up with x minus 7 is equal to -2. And then you would add 7 to both sides to isolate x. So you find that x is equal to 5. Because -2 plus 7 is equal to 5. Therefore, our oxidation state on phosphorus is +5. So whenever you encounter a problem that asks you to identify the oxidation state, or sometimes referred to as the oxidation number, on a given element within a compound, the first thing you want to look at are your hydrogens and oxygens. If your hydrogen is there and it's attached to a non-metal, it has a +1 charge. If it is attached to a metal, it has a -1 charge. Oxygen usually will have a -2 charge unless it's a peroxide or superoxide. And then your group 1 and group 2 elements will have an oxidation state that is the same as their charge, which is +1 for group 1, +2 for group 2. There are several other rules for assigning oxidation states, and you can find them in my PowerPoint presentation for this chapter.